Hi, welcome to the webinar of ETAP Star Powerful Platform for Protection and Coordination Studies. I'm your presenter, Kun Ren. In this webinar, I'm going to show you multiple powerful tools in ETAP Star mode, which can facilitate us to perform protection and coordination studies effectively. We'll discuss Protective Device Design Assessment Tool, Protection Zone Weaver, which is built on Artificial Intelligent Protection Zone Detection algorithm, and this is also the foundation for SAR auto evaluation, the sequence of operation simulation for all fault types, automatic protection and coordination evaluation, device setting report and visual comparison of revision data, and my colleague Brett will show you another powerful tool called UserDefined Fields. This tool is available in ETAP 22 release. I'll show you the application of each tool and how to apply it to your ETAP project, so that after this presentation, you should get familiar with available tools and be able to utilize them in your protection and coordination studies. Let's first look at the Protective Device Design Assessment tool. When we are doing protection and coordination studies, having all protective device data entered is the first requirement. Without having this information, we cannot plot time current curves. The application of this tool is to troubleshoot and verify the entered data for all protected devices, so that we can identify all the missing information and what are the issues we have in current project. This tool can be applied to either the selected devices or all devices inside of this project. The very comprehensive message is given for each individual device, and the device design assessment is provided in a tabular format, which allows you to do filtering and sorting. It's also available for star views, so you can utilize it for each individual star view as well. Let me show you how to use Protective Device Design Assessment tool in ETAP. I have a project open right here, and I'm in star mode. On the right side toolbar, I have the Protective Device Design Assessment tool button available. And if I press this button, ETAP will run through all the protective devices in this project and listed all the issue ones. By default, we have the messages filtered based on alert and warning. I can clear the filter to show all alert, warning, and informative messages. And now let's filter based on all alert messages. For the first row and the second row, and they are the messages for CB-IM-11, which is a low voltage circuit breaker. So when we are highlighting row 1 or row 2, this breaker is highlighted on your one-line diagram. You can tell this breaker has missing breaker and trip unit by reading this assessment detail messages. And you can double click on the CBIM-11 device ID to open the breaker editor. So in the breaker editor, we can select a model with trip unit, press OK, and press OK. You see device design assessment message is automatically updated, right? So the old messages has been removed because we have a proper model selected for CB-IM-11. Let's take a look at another message we have right here. So we have a multifunction relay. The manufacturer is back with electric. Right? The model is M-3310. And the message we have right here is ground CT not specified. Let's double click to open the the relay editor. And the input page is showing up. We can see the ground CT is not selected. So let's go ahead and select the ground CT. Select CT-U1 and press OK. Now you see that message has been removed. So this is a very useful tool that you can utilize for error checking, that before you start protection and coordination studies, running this tool will help you to identify the issues you have in this project. And then you can fix all these issues you have so you can move on easily. Another feature that you have is exporting capability, right? You can select all the items and export this list into an Excel report. Let me save this file and open it. You see an Excel report is generated, and you can send this information to your client if you're receiving this project from them, that no information is provided for all these devices. And this is a very good tool that you can always utilize no matter if you are doing the project or somebody else is doing a project. Let me show you how to use Protection Zone Viewer tool in ETAP. First, you need to select an element. Let's select IMV-11. So right now on the right side toolbar, the Zone Viewer tool is active. You can press this Zone Viewer tool and it will open the Zone Viewer. Within this Zone Viewer, you can see the IMV-11, which is the motor, and we have the motor zone highlighted. This motor zone includes the equipment, which is the motor, and all the protected devices that are protecting this motor. We can use the Protection Zone Viewer tool to create star view. With this option selected as default, we can create a star view per individual zone. And let's click Create. So we can see a star view is created for this motor. And this star view is named after this motor zone ID, which is IMV-11-1. We can create one star view for multiple zones. Let's go back to the Zone Viewer and one line by adding this TR21 transformer and this MCC-MV-1 bus. Now we have 3 zones available: the motor IMV-11 zone, MCC-MV-1 bus zone, and the TR21 transformer zone. We can choose the second option we have right here, which is create single star view, and press Create. Now ETAP is creating a star view for all these elements that we have selected from the Zone Viewer, right? It started with the motor zone and then bus zone and transformer zone. As you can see, we have all landmarks plotted for motor, starting curve, and continuous amps for the cable, right? This is the full amp of the transformer, and we have the transformer damage curve. Also, we have all the protected device curves plotted, so you can do your protection and coordination analysis within the star view. Protection Zone Viewer is using the Intelligent Protection Zone Detection algorithm. You can use Protection Zone Viewer for fast star view creation. it has a smart zone filtering capability, which allows you to filter the zones based on its type. And also you can filter the zones based on voltage. The graphic zone highlighting on OLV is available when you're highlighting the zones from your zone viewer. Another application for protection zone viewer is to do the zone filtering. Now let me close this protection zone viewer and go back to my one-line diagram. I can select all elements by pressing Ctrl A. So now you see all elements are highlighted, and I can open the protection zone viewer. So now you see all the available zones inside of this project. Of course, you can create store views for all individual zones for your study, but sometimes if you're just interested in certain type of zones, and you can filter the zone types by using this zone drop-down list. For example, if I'm just interested in all the load zones, I can filter based on load, and you can see all the available load zones are highlighted, and I can press create to create store views per individual load zone. If you're interested in a branch zone and only with certain voltages, and we can filter based on the voltage level. Let's say if I'm interested in the branch zone which is greater than or equal to 10 kV, we can filter using the zone viewer tool right here. And now I have two branch zones, TR11 and TR21 filtered out. I can create store view for both zones, and then I can study just for the branch zones that I'm interested in. Sequence of operation tool is a great tool for protection and coordination validation. It's based on the calculated through fault passing through each individual protected device. We can simulate the fault with different fault types at any location in our system. In ETAP 22, we added the slider mode, which allows us to focus on one or multiple events that we are interested in. Now let's take a look. We have the sequence of operation tool available in store mode located on the right side toolbar. So it's called fault insertion. Before we place a fault, we can open the study case. In study case, we have a dedicated page for sequence of operation. If we switch to sequence of operation page, we can change what is the fault type, what is the fault value, right? And how many protected devices to be considered based on the number of bus level away. And we can include or exclude the maintenance mode of low voltage solid state trip unit. And also we can consider zone selective interlock if a breaker has the ZSI capability. Now let's simulate a three-phase fault at this motor IMV-11 terminal. Let me place a fault right here. And you can see the sequence of operation viewer is automatically open. And we have a new slider added for the sequence of operation viewer. And it's showing a full list of protected devices sensed the fault at this location and giving you the tripping sequence right here based on the time. In the slider mode, you can study each individual device by highlighting that specific device. Right now, I have RLTL21 relay highlighted. You see this relay is highlighted on my one-line diagram as well. This is a relay element, and you see the tripping is based on the instantaneous overcurrent function, which is 50. Since relay is not an interrupting device, so it's not flashing on your one-line diagram. Okay, I can move my slider using the next button, or I can change based on the slider location by dragging this slider arrow right here. The second event is the fuse. Fuse is tripping. Since fuse is an interrupting device, so it is flashing on my one-line diagram. So let me move on to the next event. We can see the breaker is tripping and is tripped by the RLTL21 relay. And the next one, you see the upstream relay, which is a transformer TR21 primary relay, sends the fault, right? So it will send out the tripping signal to its interlocking device. And the next event right here, the CBTH21 is tripping. It is an interrupting device, so it is flashing. So with the slider, you can easily check each individual event, right? By using this previous step, next step, or we can set from the beginning or go all the way back to the end, right? So you can use these buttons or just drag and drop this slider arrow to check each individual event. So another powerful tool for the slider is you can study a filter list based on the current slider location. Let's say I'm only interested in all devices tripping less than 1 second, right? Which means I'm interested in row 1 to row 5. I don't want to see row 6 to row 15. So in this case, I can highlight this row 5 and click on this button. This is filter based on the slider location. So right here, the list is filtered based on my slider location. So I can just focus on all the devices that I'm interested in for the sequence tripping, right? I can move my slider here, and you can see this event list is automatically updated. If I switch back to the full list mode, and you can do the table or event list filtering by using the header sorting and filtering capability. You can filter based on time, filter based on the ID, by fault current, or based on the tripping time. And this is the slider mode. So we have the automatic mode, which is same as before. If you switch to automatic mode by clicking on this button, you see the devices are automatically flashing based on the number of devices to flash we define right here. So we used to have this option in study case, but now we move it to the sequence viewer so you can easily change it. Right, so right now we have 3 devices to flash. I can increase it to 4, so you can see there will be 4 devices, right, flashing on your one-line diagram. And you can pause the flashing, right? Sometimes, right, if you have multiple devices at different locations, you don't want your one-line to jump between here and there. You can pause the tripping, right, by clicking on this button. You can resume the flashing, right, and then you see flashing continues. After the fault insertion, we can create a normalized star view to study the coordination between certain downstream protected device and upstream protected device. And now let me use this RLTL21 relay and the RLTH21 relay as an example. I'm highlighting both relay and create a new star view. So as you can see here, this star view is called normalized, and it is normalized based on this three-phase fault, and the fault is adjacent to the MCC-MV-1 bus. You can see the normalized fault current is 17.749 Ka, and each individual device is plotted based on the actual through fault current. So the upstream relay RLTH21 have 4.28 Ka passing through it, and the downstream relay RLTL21 has a 4.2 Ka passing through it. So for this case, we can tell these two relays are properly coordinated, and this is based on this certain fault location. And this is very useful when you have parallel systems. So sometimes if we are coordinating protected devices based on the maximum bus fault current, they might not have full coordination. So we can run a sequence of operation to create a normalized star view, check if we have proper coordination with the through fault current. We can switch between the normalized star view and the regular star view by clicking on this button. So right now we are in normalized TCC. If I press this button, it will switch to the regular star view. In regular star view, as you can see, we are plotting the curves based on the maximum bus fault current, right? You see the clipping current is calculated based on the fault at the bus, right? So which means if you know where is a fault location, and you can identify for that fault location if certain protected devices are coordinated or not, right? So you can fix it accordingly. Another powerful feature we have in star mode is star auto evaluation. Star auto evaluation is for running protection and coordination studies automatically, and it helps to reduce months of work to few hours, and you can identify the false trippings and miscoordination easily by looking at an analysis viewer. So it's built based on this powerful intelligent zone detection tool, and we have a very comprehensive rulebook, which by default we have the ANSI and IEC standard available, and you can also customize it based on your local rule. Now let me go ahead and show you how it works. The auto evaluation tool is available in STAR mode. And let's first take a look at the study case. If we open the study case, we have a star auto page available. So here you can select a specific rule for your study. By default, we have ANSI and EC rule and also the IEC rule. We can choose what evaluation for this study. It can be for protection only, coordination only, or both protection and coordination. We can define the fault type for this evaluation. It can be phase fault, ground fault, currently is for coordination only, or both phase and ground. We have other options available, and for this, you can include the past messages in the report. Here, we can consider the zone selective interlock for the devices we have with ZSI capability. And also we can run auto arc flash evaluation by check this enable checkbox. Now let's go ahead and run an auto evaluation for this IMV-11 motor. I can highlight this IMV-11 motor and auto evaluation button will be available. If I press this button, ETAP will run auto evaluation for this motor. So in the analysis viewer, you see multiple pages available. And the first page is general page, which includes all the summary messages. So here is the motor zone, and we have two equipments. One is the motor IMV-11, and the other one is this equipment cable. For this equipment cable, we are showing allowable ampacity not specified. So if we switch to cable page, we won't see any evaluation result for the cable because we don't have an allowable ampacity specified. For the motor, we have this message does not pass phase protected device evaluation, and we have an alert. So we can switch to motor page and see what is the evaluation result in details. In motor page, I can click this motor ID to expand this temporary SAR view. Let me maximize this analysis viewer so you can see it clearly. So we have the pickup limit failed for evaluation. We have the follow amp evaluation failed. We have the acceleration curve, lock rotor current failed, and we have damage curve failed. And you can easily tell by looking at the motor starting curve, damage curve against the protected device curves we have right here. We can see my fuse is interference with my motor starting curve. That is the cause of the failure of the acceleration and LRC. And my protected device combination curve cannot protect the hot rotor damage curve. So that is why we have a failure right here. And we can see this message for pickup limit evaluation that our overload pickup is 180 amp. It is above the maximum limit of 178.6 amp, and that equals to the full amp of the motor into that 115%. And this 115% is defined in the rulebook. And we can click this edit to open the rulebook. Let's go to the induction motor page. So we can see this is our limit table that we use for pickup evaluation. And we have the minimum limit and maximum limit defined right here. And right now we are using the NEC rule, which is tracked right here. So we can take a look at the limits table of NEC. So since we are using the 115%, so we know we have a motor with service factor less than 1.15, and we can double check that by opening the motor editor. So let's click OK and press OK, and double click on the motor ID. You can open the motor editor, and in nameplate you can find out the service factor. And service factor is 1. So the start auto evaluation is smart enough to detect the service factor and pick which maximum limit to be used based on the NEC rule. So here let's take a quick look and see how we can fix the issues, right? So we know we have a problem with the starting curve, and we can increase the fuse size by dragging the fuse curve and move it to the right. So now you see we don't have any problem. We have all passes for the acceleration and LRC. The great part of auto evaluation is you can just drag and change settings inside of the temporary star view, and ETAP can automatically rerun the evaluation and update the result. So here we are good on this acceleration curve and lock rotor current curve, and we can go ahead and change the pickup. Let's change the pickup and move it to the left. Okay, so now as you can see, I move my pickup. Right now my pickup is good, right? But I have a problem of the tolerance evaluation, right? So here it says the trip curve is too close to the acceleration time. So we are measuring the starting curve with applied tolerance defined in the rulebook. And we can click edit and take a look at the tolerance we apply for this induction motor. In the induction motor page, we can see we are applying a 20% tolerance on top of acceleration curve. So which means on this acceleration time, we apply 20% time tolerance. Within that 20%, if we have a curve intersect and we are showing this too close message, right? So this option is customizable and is really based on the case-by-case scenario. And you can define what will be the tolerance for your project specifically. And you can change it right here in ETAP 22. Right, so here I want to change my tolerance from 20% to 10%, and I can press OK. You see, ETAP is automatically running this evaluation again by changing this rulebook, right? So now I don't have any problem, right? The only issue I have right here, I should not say this is an issue, and this is something which designed based on the curve construction, right? So the curve, you see the pickup is below my full amp, but the curve is actually the start right here is above the FLA. Right, this is something, a description of how the curve is constructed, and we can live with it. And after running evaluation, we can close this and generate an evaluation report. So we can go to the report manager and go to evaluation page and select this evaluation report and click OK. And ETAP will generate an Excel report, right, with this project info page, general page, and motor page. So it lists all the information based on the evaluation we just run through. You can also run auto evaluation for the whole system if you do Control All and run auto evaluation. So you get the automatically evaluation result for your whole system, and then you can play with each individual zone and make adjustment on your protect device settings to have the best protection and coordination result. STAR has device setting report in two different formats. We have Crystal report and Excel report. Excel report is very flexible that we enhance it to have the capability of showing the difference between revision and base. The changes in revision will be highlighted in this device setting comparison report. And let's take a look how you can generate a device setting comparison report. In STAR mode, if you click to open the Create Device Setting Report button, it will show the Device Setting Report Manager. So here we have the settings, which is the Crystal report formats, and Excel with all the Excel templates. So in Excel tab, we can choose this template, all devices, brief and sort with revision AC DC. So here we can use the option by selecting this drop down and choose the revision we want to generate, right? So let's say I want to generate a device setting report based on the suggested revision. And in addition, I don't just want the suggested revision, and I want to do a comparison between suggested revision and base. And this is what I can do right here. I select the suggested revision and select the radio button revision versus base. Now I can press OK and save. Press OK, and ETAP will generate an Excel comparison report between these two revisions. So here I got my Excel device setting report generated. I have my project info page. Right here, I can see this is a comparison report between suggested revision and base. And the revision setting, which is different than base, will be highlighted or is highlighted in this color. So I can go to the relay page and I can see for relay RL TH21, right, there is a change in suggested revision. In base, I have the time del for TOC set at 5.9, but in revision, suggested revision, I have the time del as 2.67. So in this comparison report, ETAP is capable of highlighting the settings change in the specific revision. So when you're submitting this device comparison report to the site, the field engineer can just modify the settings based on the highlighted items without worrying about the previous settings of each individual device. So here is relay, and we can see here in low voltage circuit breaker with trip, TM, and MCP, there's no change in suggested revision. And here for overload heater, I don't have any changes. Fuse, no changes. LVCB, LVSSC, we have one change right here highlighted as green. And right here in inline overload relay, I don't have any changes. So this is a very powerful tool that you can utilize when you want to just visually compare what are the settings change between one revision versus another. Next, my colleague Brett will show you the user-defined tool in ETAP 22.
Hello everyone, my name is Brett Rohde, and thank you for taking the time to join me for this introduction to the Protective Device Asset User-Defined Fields. The Protective Device Asset User-Defined Fields is a fully customizable template that will give our users more freedom to add user-defined fields to the Protective Device editors. The Protective Device Asset User-Defined Fields will replace the old design of the User-Defined Remarks page of the Protective Devices. With this new design, users will be able to fully customize templates where rows, values, labels, and units can be manually inputted as a user-defined field. The Asset User-Defined Fields template editor will have importing and exporting capabilities. The User-Defined Fields template can be saved and sent to colleagues, customers, or even saved on your local machine for a quick setup of the user-defined fields for your future projects. An independent data manager was created for the user-defined fields for a quick and easy way to update the values within your Protective Device user-defined fields. Excel reports will be available within our report manager. The Excel reports will include the user-defined fields, and the values can be compared between revisions. Let's take a look in ETAP on the differences between the old remarks page compared to the new design of the Asset UD page within our protective devices. With ETAP now open, let's take a look at the new design of the Asset UD page compared to the old remarks page within our protective devices. To the left, I have the remarks page shown in ETAP 21, and on the right, I have our new Asset UD page shown in ETAP 22. With the new Asset UD page, our users will have much more freedom to customize and edit this page as compared to the old design of the remarks page. You will be able to edit the number of rows included in the tables, as well as editing the label, the value, the unit, as well as the helpline shown. If we take a look at the remarks page, we were limited to the set of user-defined fields we can have, and we were limited on the customization within the labels and values. With the new Asset UD page, this is not the case. As you probably already noticed, we have two available tables shown, one for the common and one for the device specific. The common table will share the template with all protective devices. The device specific table will share the template between the same type of element, meaning all low voltage circuit breakers will share the same template for the device specific table shown in the template editor. Within the Asset UD page, values can be adjusted and saved, but if you wish to change the other fields, we will need to do so in the template editor. Let's take a look at the template editor, and I can explain how to customize your template. Here we have the Asset User Defined Template Editor. As I've mentioned before, we can see that there are two tables. We have the common table and the device specific table. As of right now, I have the low voltage circuit breaker device type selected. If we select the multifunction relay, we can see the device specific table has changed, but the common table has not. As I mentioned before, the common table is shared amongst all protective devices, as the device specific table is device specific. So let's go back to the low voltage circuit breaker. With the low voltage circuit breaker now selected, let's go over how to customize each table within the template editor. As you can see on the right, we have available options for the common and device specific tables. Each set of selections are the same. For right now, we're going to customize our common table. If we click Add, a new row will be added to the very bottom. With a selected row, more options become available. You can delete a row, you can copy a selected row, as well as paste that selected row, as you can see. And the move up, move down options will move up the row, as well as move down. Okay, now I'm going to delete this pasted row, and now we could discuss further on the columns within the template. The label column is the label that will be shown within your Asset UD page. The type column, there are 5 available types. First, we have the text type. The text type will allow up to 125 maximum characters within the default value field. The numeric type allow only numeric values within the default value field, and will be limited based off the min and max inputs you have put for your continuous range column. Steps can also be added. Next, we have the list box type. As you can see below in the device specific table, we have list box type selected here. The available options within the default value are based off the inputs you put in the discrete range. The next type we have is the date. When the date type is selected, a preset format for your date will be displayed in the default value, so you can easily input any specific date you wish. Last, we have the hyperlink type. With the hyperlink type, links can be inputted in your default value, as well as links to any local files you would like to include. Last, we have our exporting and importing capabilities within our template editor. As you can see on the bottom, we have an export and import option. If you click on export, it will take you to our user-defined fields folder within your ETAP. Here you can save your Asset User-Defined Fields template with a specific name as you wish. In this case, I'm going to click cancel. You may also import saved templates. We do have one asset user-defined fields template which I'm using right now. Okay, I've just explained to you on how to edit a template within the user-defined fields template editor. Now let's take a look at our data manager. Within the data manager, values can be easily changed or updated based off the device type selected, the device ID selected, as well as a specific revision ID. So if we go to low voltage circuit breaker CB22, I have some inputs, as you can see. Within the data manager, you can easily edit any value within your common and device specific tables without adjusting anything within your template editor. Okay, as you can see on the right, we have some available options within your data manager. If you select a row, you're able to delete rows, as well as select multiple rows, copy, change device IDs, and paste those selected rows amongst different device IDs as well as revision IDs. Last, we'll take a look at our report manager. Within our report manager, you're able to select the device type, device ID, as well as revision ID you would like to include in your Excel report. So for this case, I am going to select low voltage circuit breaker, CB22, and include base as well as alternate mods revision to this report. Let me make this a little bigger. So now, as you can see within our report, we have different colored fields. These fields are based off this different cell color. This different cell color is showing up because we have different inputs based off our base revision compared to our alternate mods revision. This is very helpful in terms of making changes to different revisions based off your protected devices. For instance, if you were going to change a trip device within your low voltage circuit breaker, you can show this within our report. You can also show maybe things that aren't within our device report setting, such as a part number, a serial number, specific settings that we do not include, or a specific date of inspection or date planned, however you wish. This color can be edited, as you can see if you click on fill color, as well as the actual text color. It's fully customizable. Let's check the option open it in Excel, and then let's click on report to create our report. Let's save our report. Click yes. As you can see, it is loading. And now we have our Excel report for our asset user-defined fields. This report can be included in any Excel report you wish. You could just add it to a tab. Very useful when it comes to that. That is the end to the introduction of the asset user-defined fields within your protective devices. Thank you.
Thank you, Brett. That concludes today's presentation. Thank you so much for your attention. We're looking forward to see you in next available ETAP webinar.